Software Engineering Radio Episode 82, Organization of Large Code Bases with Jürgen Höller. Welcome listeners to 2008. It's the third year of Software Engineering Radio. To be precise, the first episode was broadcast on January 26, 2006. So we have another 2 episodes to go, or 3, until we have our official 3rd birthday. But anyway, welcome to 2008. So if in calendar years, this is the 3rd year. Before we are going to talk about large code bases, actually before Eberhard is talking to Jürgen Höller about large code bases, let me again remind you of the fact that we have this Software Engineering Radio Get Together 2008 thing on our website. This is the mini conference we're thinking about, an open space event. We need to know whether you're interested in participating, whether you want it to happen in German or in English, and all these other organizational things. So please visit se-radio.net. On the left side, there is a black banner. Basically, it shows a campfire. Just click on it and please reply to the bunch of questions we have there. It helps us organize the get-together and see whether it makes sense. Okay, so this episode is, as I said before, a discussion between Eberhard Wolff and Jürgen Höller about large code bases using the example of Spring. And also you should know that Eberhard and Jürgen both work for Interface 21, or I guess they're called Spring Source now. So if you think this is advertisement, which I don't think, but if you think it's advertisement, then just stop now and listen to the next episode. Otherwise, have fun.
So, Jürgen, do you want to say a few words about yourself and the Spring Framework?
Hi, everybody. I'm Jürgen Höller. I've been co-founder of the Spring Framework project back in early 2003 and have been involved as lead developer and release manager ever since. The Spring Framework is a well-known open source project in the Java middleware web application space. It's a broad application framework just offering facilities for managing the internals of an application service layer, of a web application, of any kind of internal structure of a typical Java-based business application in most cases. Well, Spring has the Spring Core, so this is what we usually refer to as the Spring Framework, as well as a number of sister projects, such as Spring Webflow, Spring Web Services, Spring Security, and so forth. Okay, so
obviously we are going to talk about the specific issues of developing frameworks and how to evolve them. One interesting thing to cover first is how is Spring actually developed. I mean, it's an open source framework, so you could assume that it's done in a distributed manner. How do you do that?
That's roughly how it works.
Okay.
So we're probably not unusual in that respect. For open source frameworks at least, Spring is largely developed by a distributed team, of course, with occasional quite regular face-to-face meetings between members of the team. We have a quite large number of committers, more than 30 in the meantime, for Spring Core, that is. But probably pretty common, like in most open source projects, there is a smaller number of core committers, about 5 now in our case. We have a large number of contributors, some of them having commit rights, some of them not having commit rights, and just dropping pieces of code in every now and then. But in the end, most of the work done on core Spring is within the hands of very few people, really, which we need just to keep the code base coherent and evolving the code base in an organized fashion.
Okay, so obviously we will not talk about how to organize large teams and all the organizational issues that come with that, because Spring is not a good example for that. It's more a good example of how to evolve a framework. Why should I even care about code organization in the first place? What is the problem if I don't really care about it? What's the outcome of that?
Well, for a start, there are quite a few people who don't care about code organization. I would argue it's pretty obvious if you look at a lot of the code that's out there today, even and in particular in the open source world. Well, what happens if you don't care about code organization? It probably doesn't show in the first cut of the code that you do, but over time, if your code base grows larger and larger, more sophisticated, integrated with all sorts of third-party code bases, then management of a code base becomes a serious issue. The typical effect is that at some point, your code base turns into one large chunk of code with no clear distinction within the code, with no clear boundaries between subsystems, modules of the code, and as you can imagine, it's pretty hard to maintain that sort of code base over time. This can happen pretty quickly. So even if your code base looks clean this year, just in a year's time, your code base might have evolved into an unmaintainable beast. There is a number of well-known problems in that space. I mean, probably the most prominent being just unclear dependencies between packages, between modules, conceptual modules of your code, showing as a circular reference within within the overall code base. So circular references at the large scale level within subsystems, or even circular references within small sub packages within a module, which still may turn into a maintenance nightmare over time.
So what is the actual problem of such a circular reference?
The circular reference, the famous circular or infamous circular reference, is a common problem. So if you look at code bases out there, a lot of them have circular references.
Can you give an example?
Let's start with something pretty well known. Take a look at java.lang and java.util, which, of course, have been around for a while, about 12 years, and have evolved into a tightly correlated piece of code. So java.lang and java.util are, of course, co-evolved by the same people, but they effectively are one package. They aren't separated anymore, because java.lang depends on specific parts of java.util in all sorts of places, and java.util, of course, depends on java.lang. There is Java I/O involved in between, so that problem is actually a bit larger than just lang and util. But it's if you just navigate through the JDK source code, you just find yourself jumping between lang and util and I/O all the time. So if you look at java.lang.string, which might implement some interfaces from the I/O package, such as serializable. Of course, the I/O package depends back on the lang package for the core language artifacts. With the java.util package, they introduced the collection framework in Java 2. This essentially turned java.util into a very central package, which all sorts of other parts depend on, including Java.lang. So the JDK is a good example for anybody interested in source code organization. Have a look at the JDK and learn some lessons.
Yeah, and the point is that in the JDK, the problem is probably not too large because you don't want to evolve the separate parts of the JDK anyway. While in Spring, the goal is really to have separate modules that can each and every one of those can be reused independently of the other modules. So it's not just about the maintenance of the code that is hurt by the circles, but also the reusability of those modules.
Yes, this is arguably a problem that doesn't really show in the JDK. It shows in code that's more loosely coupled, sitting in higher levels of the stack. Where you just don't want your code base to be one big single unit of development and deployment. You want to build independent, distinct subsystems, distinct conceptual modules, which just interact at runtime. And this is what Spring is really designed for. Spring is a collection of pretty independent subsystems, which may be used independently. They are designed to be cohesive units on their own, independent as far as possible or necessary. And of course, they can be used as in framework style, just combining, say, the AOP framework, the core container, maybe transaction management into one single framework stack. That's then how Spring is usually seen out there in the wild.
Usually Java systems are organized in terms of packages because that's what the language gives us. Is that also the case for Spring? Is that enough, or are you using other metaphors as well or other techniques?
Java language packages are certainly a core element of any kind of source code structure, source code organization. The problem with packages is that they're just not quite enough. With standard visibilities, you may just define visibilities at the package level, so visibility within the package or visibility to the outside world. This is a bit too coarse-grained. I mean, the outside world might fall into quite different categories. In the case of Spring, we have this problem at the SPI level mainly, where some parts of the framework just use other parts of the framework, interact with other parts of the framework, but not necessarily with user visible API. So this sort of API is what we usually call internal API. So it's of course still an API. Some sister projects, external code, might use those, but they're not necessarily what typical applications use. So with anything that sits in between, it's not quite the public published API that you have out there, what I sometimes call a public API, but it's not internal to the package either. Other packages need to see specific hooks and so forth. This is what the Java language or the Java package model just doesn't offer. So within Spring, we do use packages, of course. We build top-level packages for each cohesive subsystem, more or less. There are certain exceptions where the packages are a bit more fine granular. But in general, we've got top-level packages such as AOP, beans, context, transaction, DAO, web, which just indicate a distinct part of the framework. And within those packages, we then differentiate into sub-packages. So we've got the central interfaces, API hooks, SPI hooks, common exceptions, and then specialize those parts down into sub-packages. So we are building on sub-packages a lot and using sub-packages in a very specific fashion where we try to identify even even within a subsystem, within a module, we try to identify distinct responsibilities and build specialized code for that, specialized implementations into distinct sub-packages, which, well, has a number of positive implications. As maybe the most obvious one, you can use those parts independently, but for our purposes, it's actually more important to be able to navigate through the code base, to be able to just find out which part of the code base, even in the details, is responsible for what part of the functionality. So to find yourself within a package if you try to track down a problem or try to add some new functionality, rather than jumping around all sorts of packages when you try to implement a single specific feature. So we try to follow that principle as far as we can.
So that's quite interesting, because what you're basically saying is that the package mechanism in Java by itself is probably not enough. Instead, you have to have something like more coarse-grained packages and sub-packages, which is also something that other technologies such as Maven, which is a build tool that is building up build modules, which are obviously more coarse-grained than just a single package, or OSGI also come up with. Now, is that a technology that is applicable in some way to Spring, or how does that relate to the approach that you are using in Spring for this kind of problems?
It is related. Maven, of course, is mainly a build time tool, so it's about turning your source code into deployment units, deployment artifacts. Of course, this has a quite direct relationship. Whatever you do within your source code, however you structure your source code, is going to show effect at the distribution level. In many cases, you define a conceptual module. You find conceptual boundaries. You try to establish conceptual boundaries, indicate those boundaries within your code base. This might turn into separate source directories where each and every of those subsystems sit in a separate source directory and are probably compiled into a separate jar file. That's not necessarily the case, though. So you might also have a single source directory, maybe even just a single or a very few jar files, but still try to design your source code to be as loosely coupled as possible within that single source tree. So the same mindset shows when you build deployment units, such as jar files, but it's mainly about the conceptual model that you've got in your mind when you come up with the source code structure in the first place, when you evolve the source code structure, and when you just try to navigate through the source code structure, where no jar file or anything else is even in the picture.
So it's not just about using the right tool and having a tool to support you, but it's also about how you generally organize your code and to have those conceptual modules in place before you think about which technology you're actually using, which is probably a quite a good idea anyway. So the other thing, we've been talking about packages and modules. And now if you look at your typical sort of PowerPoint architecture of a business system out there, usually people tend to think in layers. Is that something that you can identify or use in Spring as well, or is Spring somehow different because it's a framework and the layering really doesn't apply to frameworks?
Layering, of course, is a pretty important concept in itself, but it's a bit orthogonal to modules to some degree. For a framework, layering is not that central. So you may be able to identify layers, and within Spring there are layers of functionality, just lower layers and higher layers, where the higher layers depend on the lower layer functionality, but not the other way around. So obviously we do have that sort of relationship, but the primary notion of code organization within the Spring code base is conceptual modules, with each module being loosely coupled to the rest of the modules, but highly cohesive within the module. So this cohesion, this notion of cohesion, isn't that central with layering. Layering often has to do with, even deployment, where your user interface layer maybe is deployed into a separate virtual machine, service layer, application layer running in a server-side process. So in a typical PowerPoint kind of diagram architecture, you'll probably identify some coarse-grained layers and some modules within the layers. But from the original idea of a conceptual module, layers are secondary, in my opinion. The primary notion is a module, because if you have a concept essentially with conceptual boundaries, this conceptual module will involve both some DAO, data access related parts, some process calculation, whatever related parts in the service layer, maybe some stuff in the user interface layer. It's all part of the same concept that you introduce into a code base, and layering is not quite that important in that respect. Within a typical application architecture, things are different. You usually start with layers, although you might define modules up front. Modules are should be more common even in application architectures, but generally speaking, a framework, a library, is a quite separate affair. In application architecture, other factors play an important role. Within the framework or library, you are in a quite different kind of world in that respect.
Yeah. Speaking of which, the other thing you already mentioned that is that there are those public APIs which that are used by the users of the framework itself, and cannot really be changed anymore. So that means that certain parts of the code itself need to be stable, So how do you actually deal with that? How do you keep your architecture clean while still being able to maintain the backwards compatibility for the public APIs?
This is probably the biggest challenge in it all. This challenge is I guess more common in frameworks and libraries than in applications code, since within an application you might just follow typical agile processes where you are in full control, hopefully, of the code base, and you just refactor whenever it's necessary. So if you introduce a new concept into the code base, major new functionality, you might just do some refactoring, which breaks packages. You might completely restructure your code. It doesn't matter as long as all the callers are under your control as well. But in a framework, in a library, in any kind of code that's published to the outside world with unknown clients or unknown number of clients, things are of course different. We within Spring, we need to preserve our public APIs, so those most central parts of the API that many applications depend on in one way or the other. Those need to remain stable. We need to preserve backwards compatibility. We might be able to introduce new functionality there, new methods. We've got lots of interfaces where clients typically call into, but essentially the implementations of those interfaces are all part of the Spring code base, are all under our control. In that case, we just introduce new methods if necessary, but all present clients will find a compatible API, the compatible API that they expect. In other parts of the system, it's a bit more subtle. if from the pure client's perspective, we establish 100% backwards compatibility, but we also offer lots of extension hooks, lots of customization hooks in the Spring code base. And the challenge is much harder with in that space with those hooks, since if we introduce new internal functionality, if we do some internal restructuring to optimize things, to address new requirements coming in, we need to refactor internals. And this sometimes, or quite often actually, does affect customization hooks, extension hooks. So what do we do with people having implemented some of those customization hooks, having done some custom subclasses, overwritten some protective methods? That's the biggest challenge. And we try to preserve, let's say, a 99% backwards compatibility even there, using deprecation and so forth. So we really strive for making people's life, not making people's life hard without a good reason. But in some cases, it's necessary to just really refactor a customization hook, where some new method argument comes in, some new context comes in, something changes within the internals that just doesn't allow for keeping existing customization hooks in that space. Sometimes we have to decide on that. We try to do creative refactorings, preserving compatibility as far as possible, but if necessary, for introducing new functionality, for preserving architectural quality, for not compromising on architectural quality, then we change those extension hooks, customization hooks, and just document it so that people using those hooks have a clear migration path nevertheless.
So can you give an example of such a creative refactoring?
Well, there are quite a number of creative refactorings that we used over time. I guess the most obvious cases are in the core container and the OP framework, where the interaction between those depends on SPIs that the core container offers, and the OP framework uses them. And we allow people to build custom subclasses of both the core container classes, the AOP framework classes, in this case, the so-called auto proxy creator, proxy factory being, and those classes. So people do use those customization hooks. We learned that quite a lot of people use them just by bug reports, issue reports, enhancement requests coming in. So we try to keep the established structure there, introducing new functionality on the fly. Sometimes this means introducing extended SPI interfaces, a concept that we came up with over time. Example would be the bean post processor, for example, in Spring. The auto proxy creators use a bean post processor. It's a general hook, so other implementations might implement the bean post processor interface. We had a number of times we had to introduce new callbacks. So the auto proxy creator had a need for extended callbacks. So how does the core container give those extended callbacks to the auto proxy creator if there is an established bean post processor contract in between, and other people might rely on it?
So what we are basically talking about is a general concept, the bean post processor, which allows you to have each and every single component inside the Spring container be modified in a certain way, and the responsibility of the auto proxy creator is to modify certain Spring components, Spring beans, in a way that, for example, AOP stuff, aspect-oriented advices and so on can be added. Now, obviously, you need to change the auto proxy creator from time to time, and the question is, how do you do that if other people already have rely on the same interface that is implemented by, or that can be used to modify each component, which is the bean post processor. So how do you do that?
This is what led to a number of extended bean post processor interfaces. So what we use is different levels of bean post-processor, there is the standard interface having just 2 callback methods. And for any kind of code needing extended interfaces, there are sub-interfaces, extended bean post-processor interfaces. The so-called instantiation-aware bean post-processor, destruction-aware bean post-processor. Any kind of code that needs more than a standard bean post-processor uses those. We apply different compatibility levels to those. So in general, it's recommended for any kind of client code that wants to do custom post-processing to implement the standard bean post-processor interface, which will remain 100% backwards compatible. Whereas instantiation-aware bean post-processor might change in major versions, so with major versions jumps. So it's one of those ideas you can apply where you just clearly differentiate between sort of standard hooks with 100% compatibility guarantees and extended hooks, which might change a little over time, and your own code building on this, of course, using the extended hooks, applications hopefully mainly using the standard hooks.
So basically the idea is to have sort of the standard interface, have other interfaces inherit from those, and then use the right level of interface for client code with public APIs, and internal code might use other more fragile interfaces, so to say.
More sophisticated and more fragile.
Yeah,
exactly.
Okay, so so Spring has already evolved quite a bit. It started obviously in 1.0. Then there were the 1.1 and 1.2 releases, and now for I think about 3/4 of a year there has been Spring 2.0 out there with quite a broad API. So how did the project evolve over time? Do you do any kind of metrics about that? And are those metrics worsening, or are they improving? What is your approach in that area?
We do use metrics, we do use tool support, and we also use metrics. So we try to come up with numbers indicating certain characteristics of the code. In general, we are pretty code centric, so we just do at specific points of time comparisons of current metrics. In Spring, the evolution from Spring 1.x to 2.0 has shown that the internal structure of Spring actually improved. So the typical metrics applied here, they actually are slightly better in 2.0 than they were in 1.2. This is largely because Spring 2.0 introduced new areas of functionality, which are pretty decoupled on their own. So even if the code base grew larger, the internal structure of the code base remained clean and became even slightly better because we did some refactorings internally, which we were able to do for 2.0, which we didn't want to do earlier. But in general, we did preserve roughly the same internal quality level indicated by those metrics.
So what kind of metrics are you actually using? Lines of code, or what do you do?
Well, lines of codes is probably one of the not so great metrics in this world, since the lines of code in Spring are actually pretty high because we use a lot of internal comments, which of course increase at least lines of code in the source file. What we mainly use here are average component dependencies. So if you take a specific component with a specific class, for example, within the code base, how many other classes or artifacts within the code base does this class depend on? This is very, very low within Spring. In comparison to other code bases because of the decoupling. So if you take any class and just look at how this class works, even from its implementation, there's just a limited number of classes that you have to go to if you just follow the dependencies. If you just open the source file, navigate down the imports, it's still a pretty reasonable small number of classes. In other code bases, this might be very different. So other code bases are often structured to import 2/3 of the rest of the code base in one single class in extreme cases. So there are very, very different kinds of code bases out there in that respect.
This is probably a good metric because it basically means that changing one piece of the code influences just little of the rest of the code, which means that the code base is changeable and easy adaptable to future requirements, basically.
And it's generally more maintainable, but indeed, in particular, it's more extensible and adaptable. Just because if you change some specific part of the code, that this is a pretty separate, distinct part of the code. It doesn't have an impact on all the rest of the code base. Of course, primary effect is you may use those parts pretty independently. So you can just take a small part of the code base and use it on its own without having the rest of the code base on the class path even.
Yeah, which means that you can use each and every feature of the Spring framework more or less independently.
Probably not each and every, but large parts.
The main ones, yeah. There are also quite subtle issues, like, for example, in every project that at least I've been to, there is usually some kind of util class or even util package if the project is sophisticated enough. So I learned that even though this package is subject to the strict requirements of package dependency in the Spring framework, and there are even on this level there are some issues with regards to the dependency management.
Yes, this is probably showing our general approach at a very low level. Even if you build a util kind of package with all sorts of functionality that doesn't fit anywhere else, collection of static methods, stuff that really should be in the JDK but isn't. That sort of stuff often ends up in a util package. And in libraries and frameworks, most libraries have their own util package. So just because they need to keep their dependencies minimal, their external dependencies minimal, all they do is they include the utility classes that they need. In Spring's case, we have a util package, org.springframework-util, which is a public package. So not only is our own code, our other packages, AOP, beans, transaction, and so forth, building on some parts of that util package, it's also available for client usage. So we do preserve backwards compatibility, client applications and extensions, third-party frameworks, third-party extensions, and so forth may use that package. We've also got a so-called core package, org.springframework.core, which is also very low level, looks a bit like a utility package, but it's actually one small level higher. So it sits on top of util. Core is allowed to depend on util, to refer to, say, static methods in util. But util does not know core, so it's not aware of core. And the core, it of course is not allowed to depend on artifacts in the core package. This is sometimes showing subtle effects. So one problem being that, for example, Spring's JDK version class and Spring version classes sit in the core package. Even Spring's nested runtime exception sits in the core package. The resource abstraction with class path resource, file system resource, and so forth sits in the core package. So according to the established rule, none of the methods, none of the utility classes in util is allowed to use any of that core functionality. This is sometimes a bit hard because you might find yourself tempted. There's that nice abstraction in core. We could call the JDK version check there. We could use the class path resource class. We could use Spring's own nested runtime exception with its own nested exception reporting. Well, yeah, you could, but you're not building a utility class then. So the idea is, util is really the lowest level of code within the entire code base. It must not even depend on established Spring things, Springisms. So it should be as minimal as possible. Usually, not even having a requirement for nested exceptions. Shouldn't be doing any JDK version checks, or even Spring version checks. And if it does some resource loading, it should do it as simple as possible, operating on input streams, operating on, maybe Java IO file handles, but not using Spring's resource abstraction, because the resource abstraction sits one level higher. It uses the util package to implement the resource abstraction, so the util package must not depend on the resource abstraction itself. Else we run into a circular dependency. So that's one example. That's probably pretty common because a lot of code bases have a util package, where just this dependency management in the details shows. If you look at code bases out there, application code bases sometimes, they often got a util package. But if you then look at the dependencies of that util package, you find the util package importing 2/3 of the rest of the application, because what you implement looks like a utility method, but it depends on core concepts of other parts of the system. So it doesn't fit into the util package. It's, I guess part of this is about util sounding so general, and people just thinking, what I'm about to implement sounds like a util method. It doesn't matter what it sounds like. It's the only thing that matters, and that determines the place where it should end up in, is what does it depend on? What kind of concepts does it refer to? That's where it has to sit. And sometimes you have to introduce more specific util packages. And that's what we do in Spring, for example. We have org.springframework.web.util package. We have an org.springframework.aop .support package with util stuff in there. So we just introduce more specific utility packages, which then implement the more specific utility style stuff. But that's a separate affair from this low-level util package at the very bottom of the dependency stack.
A typical part of Spring is the dependency of to many third-party classes and third-party libraries, and of course also to support different versions of those third-party libraries. So what do you do about these? I mean, it basically means that you have the same class, and you have different versions of that class that you need to support. And as Spring doesn't really have a versioning system based on the classes, there need to be there are clearly some issues associated with that thing. So what do you do about that?
In Spring itself, at least in the core, we fortunately don't have many external dependencies, but in, let's say, the more middleware-oriented packages, subsystems within the Spring core distribution, we do have, and as you pointed out, those third-party packages or third-party products tend to change over time. So, for example, we've got dedicated Hibernate support, and Hibernate evolves. Hibernate 2.1, then there's 3.0, but even from 3.0 onwards, there's 3.1, there's 3.2, and there have been some changes in the details in Hibernate's own API and configuration API in particular. So what we need to do in some places to preserve compatibility with earlier versions of those external libraries is just to do reflective checks. So we essentially do a runtime detection of the concrete version that's available in the class path. Say we check whether there's the Hibernate in the Hibernate transaction API, whether the set timeout method is available there as a concrete example. We just do a reflection-based check, and if it's available, we are using it. If it's not available, we're just throwing an exception if we can't implement our functionality then, or just going on with an alternative way of achieving the same end. This allows us to remain compatible with earlier versions of the libraries, which in turn allows our users to keep using those earlier versions. If there is somebody using Hibernate 3.0.5 and is happy with it, we don't want to force an upgrade of Hibernate just because the version of Spring has been upgraded. So even from Spring 1.0 to 1.2, 2.0. Even in that case, we did preserve compatibility with earlier versions to a large degree.
Okay, I see. So, final question, of course, is what do you do about the architecture? I mean, we have already been talking about some metrics. How do you actually get them? What kind of tools are you using for that?
We've been using various tools over time. Originally, we've been using JDepend, which is probably the simplest of them all. It's just a command. We are using it in a command line fashion. So essentially just tell JDepend to scan your code base and generate a report about the code base. And within that report, you get all sorts of metrics, and in particular, a package dependency section that just shows concretely where your packages depend on other packages within the system. JDepend isn't extremely smart or sophisticated, and it doesn't have to be. It just shows standard metrics and standard dependency analysis at the package level. There are obvious strategies there. Just a package shouldn't depend on any other package that in turn depends on the same original package. So JDepend doesn't have to be configured. You don't have to tell it, oh, those are my modules and so forth. You just apply it to an arbitrary code base and get some general results.
And it's free.
And it's free. And it's been around for a long time, and it works. So we're still using JDepend, just to be on the safe side. We always run different tools and see what they tell us about our code base. In the meantime, in the past few years, newer tools have been evolving, such as SonarJ or Structure 1-on-1. Tools with a GUI rather than just a command line, and tools that in particular allow to be configured for your particular code base. So you can instruct the tool, you can configure conceptual boundaries or module boundaries between your different modules. You can associate packages with those conceptual modules, and the tool then performs not only package level dependency analysis, but also module level dependency analysis. So those tools are significantly more sophisticated. But for basic purposes, even JDepend is a good start, and we're still using it as a sanity check.
So to sum up, obviously the evolution of frameworks is tricky, especially because of the public APIs that you published and that people out there are using, and you need to maintain backwards compatibility for that. We had some discussion about how to deal with that. We also discussed packages and modules and interdependencies, why they are important, and also talked a little bit about some tooling for that. Anything you want to say to sum up? Any concrete rules you want to give the audience?
Well, I guess the gist of this story is that a code base, in particular a larger code base, is pretty hard to evolve over time. But there are general guidelines that we learned, lessons that we learned in the Spring project that I assume can be applied to similar projects. And there are some lessons learned even just for any kind of code base, really. The most fundamental problem from my perspective is just this difference, or this contrast between backwards compatibility requirements on the one hand and an agile development process on the other hand. I would generally recommend to, of course, be creative in your refactorings. Try to preserve the existing structure, or at least preserve the existing structure as an entry point, even if you introduce completely new functionality as far as possible. If that doesn't work out properly, if you don't feel happy with the solution that you came up with, or if it just doesn't look clean, then don't be afraid of broader deprecation or even breaking compatibility if necessary. It's probably just unavoidable in some cases, and as long as it's documented properly, and as long as your users and extenders understand why you had to introduce this change, it's usually not that big of a deal.
Okay, so thanks a lot for this interview, Jürgen, and thanks for listening.
Thanks, it was my pleasure.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.